Welcome, folks. Hope you're having a marvelous Thursday. This is a part of ESAB University sponsoring Weld-On for National Welding Month. I have been, let's see if I can get this out, I've been countered with the cosmic character, Master of Moab, Mr. Ian Johnson. That guy did a bang-up session last week, and it was good on TIG welding setups and TIG features. I have been tasked by the viewers, yourself, to tackle some of the subject matter on entry-level basic welding joints. How do we weld them, what settings and stuff like that. I have a Rebel 235 behind me. I peeked in there hoping that I would see the chart on the inside of the door. I know there's one around, but it's not in there. So it's kind of, for me, it's kind of by memory and stuff. So I will have my compadre read off some questions on occasion when we get down into the settings and stuff. Right now I'm going to have him close the door, if you would, please, sir. Some of you know me well enough. You know, things happen in life here, and I'm going to ask, has anybody ever had a bad day? Yeah. Anybody ever had a bad week? Yeah. A month? You know, I mean, things have been rolling along here, especially with all the activities with the virus and the constraints and the lockdowns and stuff like that. I've been trying to set up my students with just broken TIG rig, just a head and a piece of fiddle wire and some coupons so they can practice the hand-eye coordination. I've also been getting other material out to them. With that, I would like to say welcome. We had a little fun yesterday. Had some folks laughing at me with my attempt yesterday. If you were on board, I was on a conference call, and that's why my audio was automatically knocked out, and I apologize for that. I've got a computer in here that I'm trying to marry another camera with, and it just didn't want to be, just didn't want to show up on there. But I had that figured out, actually. I got it last night. I want to give a shout out to my supporters, CMR Fabrications, Las Vegas, Up in Smoke Apparel, and Illumareel. Those gentlemen have really been giving me some advice, as well as a gentleman with Blue Demon. Brian has been really stepping up and advising me along the way here. So with that, let's get into some basic shop talk here. I got some things scattered here, and that's fine. That's what I do when I create. The first thing we want to cover is PPE, obviously, your personal protective gear. I almost ruined mine a minute ago. I was going out to the other classroom, and I thought the door was going to open, and it didn't, and I bit the daylights out of my glasses here, so I got to fix those. Your vision, your gloves, your long sleeve shirts, anything. So there are numerous hazards in welding. High pressure gases, electrical shock, UV, light. I mean, it's there, but if you are aware of your surroundings, smart, pay attention to stuff, you'll be fine. You'll be fine. I've been doing this a long time. You know, things happen. I just got a little grinder cut a minute ago because I was in a hurry to get some stuff cleaned up. I was cleaning up some whoopings. You know, things happen, but if you pay attention, slow down, it's really not a problem. But your personal protective gear, vision, I mean, invest in quality. ESAB has some really fine jackets, their gloves. I don't have a pair of their gloves right now. I looked for them earlier. I must have put those away when I got back from AppTech. It's important that you wear that, and I see people cutting corners, and it just makes me cringe, especially when it comes to vision. I was talking to a young man the other evening, and he says he does these certain things, and he was telling me what it was, and I'm going, oh my goodness. You know, cover one eye right now, and then go drive your bike down the street or something. Your vision's all messed up. Things can happen within a microsecond in time. You're not going to get that back. Some of us have been doing something, operating a piece of machinery, and you know, drilling a hole or something and the material bites in the bit and starts spinning around, and you're going, you know, I knew that was going to happen, one of those moments, you know, but you can't get that time back. So safety is vital. Personal protective gear, invest in quality. You'll have it for a long time, long time. Machines and machine shop atmosphere, cords, cylinders chained up, your machine set, I'm talking about the set up where you're not tripping over ground cables. See, I don't even have mine hooked up. I've been trying to weld for 40-something years without a ground cable, and I still haven't been able to do it. I keep trying for some reason. Trip hazards, basic shop cleanliness, that is important. I have worked in some enormous jobs in the past, building some gigantic boilers. When I say gigantic, 150,000 pounds. And after a while, so many activities going on and so many people. If you're not monitoring that situation, you can have all kinds of stuff cobble up around your feet. It becomes a trip hazard. You got to watch what other people are doing, lifting, rigging, all those kinds of activities. You really need to have an awareness of what's going on in the shop to work safe. So, with that, are we getting some good high-power questions yet? So we were going to get into the basic weld joints. I think the question coming from corporate was, what are some weld joints that can be done with MIG? All of them. I mean, everybody tries, which I think is a little bit of that can cause a problem at times. Not everything should be welded with MIG. It is an extremely beneficial process. Done correctly, I believe it is one of the most valuable processes that manufacturing has seen in many, many years. It is easily misunderstood. Easily misunderstood, in my opinion. In my opinion. Management wants you to just turn it up, slobber it on there and go. You know, we as welders and performers like aesthetics. We want things to be, but we want it to look nice. But is it actually in there correctly? So that's where your codes, your certifications, your standards come from. In that subject area, that's deep, but again, common sense. I've helped a lot of people on my Instagram page. I get a lot of questions daily, nightly. I know that drives some people nuts, but sorry about that. I like to answer those questions and try to help out if I can. I don't know everything, but I sure learn. If I don't know something, I'm curious enough to go look it up. I really am. I will look around. I make phone calls. I'll call somebody for advice. So people have been asking me certain settings on things. How thick of material can you weld with MIG? That's a wide open question. I have no clue what size wire they're on. I don't have any idea what gas they're running. I don't have an idea of the type of material. There's all kinds of variables. We call them essential variables when we get into codes and standards. The essential variables. I call it a recipe of sorts. I've called numerous people back. They'll write me a question and it looks like a paragraph or a book in my phone, but I want their phone number. And the first thing they ask is why. And I said, well, I'm not typing all that out. That's a big, long answer. But I have questions. In order to be able to answer your question, I have questions. And it usually, most always, comes down to a recipe. By the way, folks, I'm out here in my shop. I have no control over if you hear some background, I think you just heard a little dragon pop off there. That is a condensation drain on the air compressor. It's not timed. It comes on whenever it wants to, and it usually just scares me. Another one is the old dinosaur heat and air unit we have up here. It may come on and screech real loud. I'm used to it. You'll probably jump. I won't. The other one is the air compressor up there, and I may just stop talking for a bit. We'll see. Anyway, got to have that recipe, and that recipe entails your joint configuration, be it a lap, a T-joint, outside corner, bevel. I don't know what you're doing. It entails the type of machine you're on. It's nice to know the capabilities. I'm familiar with most of these. Some of them I have not run in the Rebel line. Anyway, that background information helps so that we can get to gas type, voltage, wire feed, speed, inductance, start, features, any of that kind of stuff. So let's start out and talk about, well, I mean, when we start welding, what do we do? What's the very first thing we do? What do you do there, Paisson? We did a little pad weld, right, with MIG. We do that in every process. We take a piece of material and clean it up from the mill scale. By the way, you can zoom in on this, sir. I've got this prepped up here, and this part is clean of mill scale. This part is new steel, but it still has the mill scale on it. Okay? That makes a difference. It makes a difference in wire feed or MIG welding in that, in my opinion, again, mill scale starves the weld pool of fluidity. Fluidity is that wetting action that we could get where the weld metal flows into the parent metal. So if you clean your material of mill scale, you can have better results and it should run smoother, pop less. We'll take a piece of material such as this and we'll clean it all off. We will take a straight edge of sorts and really don't need to start with. You can run a weld along the very edge of a piece of material, and it's there, and it has a certain height, and it has a certain width. And it, done correctly, it looks like a nice rounded bead, and the toe of the weld blends into the parent metal. It's not stacked up super high. It's not cold. It's not, it's not just sitting up there. Too hot would be a lot of BBs, buckshot, spatter, whatnot. You can clean the edge of that weld and always use it as a guide. You can always use it as a guide. So if I put a mark along here, along the edge of my piece of material, and I started out and I just wanted to point the wire at that mark, and I could build a straight line on there. After I have that straight line on there, if I couldn't see it well enough, I would probably take a piece of soapstone, or, one thing I haven't welded over is Sharpie mark, or not Sharpie mark, but the Markov marks, the silver ones. I haven't welded over the top of those. I don't think it caused a big problem. Soapstone, highlight that area, and then weld over the top of it. All of your welds should blend together. Do we have a blended plate somewhere, a dummy plate? I call them dummy plates because everybody writes my name on. You should be able to blend all those welds together. I thought there was one right down here.
There is.
And with every process, we do this with every process and we practice.
That's TIG.
It doesn't matter. You can have two with TIG too.
It's a little dirty, but
everything's dirty, right? I use these pieces of material I put them around because I'll be doing something to fit, or I need to set my machine. As Ian mentioned last week, you don't see professional welders just walk up to a project that's fixed and ready to go. So it's kind of like this. This person attempted to do the exercise. Well, this is with TIG or gas constant arc welding. You can see a series of welds down through here, and they should be blended together. The completion of this exercise, you go on to the next step, which is joint configuration. I know I had my T-joint over here the other day. I told you I never really wanted to. Oh, here it is, right here. So, maximize material. Maximize material. In my classroom and in my coursework in my lab, we start out when we run a single weld down through here. This would be a T-joint. We would run that fillet weld in here. And from there, we would start running multiple beads and stacking them together, building this up a little bit, running straight lines, same width, same height. You've already done it. It should be easy for you. Okay. This was the TIG welding process. We don't waste anything material-wise. We're running on edge in here. We'll run beads all over this thing just to get used to practicing and building up multiple beads. And here's why. The flat plate that we had, just a piece of flat plate. If we're running them in the flat position, we're good. We check off on that. We tilt this bad boy up progressively. I like to do things progressively. I'm not going to take somebody from flat to overhead. I'm going to take them from flat, and I'm going to start increasing to the horizontal. Horizontal, we call it in here. Everybody hates the horizontal because it's difficult. It's out in space. Well, if you can run straight welds across your plate, and you can blend them all together, and they're just beautiful. That's like your signature, and it's out in space. Guess what? When you get to a groove weld, a groove horizontal, you've already done the cap. You already know how. It's that easy. Vertical, same way. With the exception of weaves versus stringer beads, and we can talk on that subject as well. That's good stuff. I should be welding. Make sure that you're commenting and asking some good old questions. I'll certainly try to answer them. If I don't get to them, some of them today, I will definitely sit down and do a response video. And by the way, people, and I appreciate the following. I got to say this. I am beyond humbled to be in this community, in this atmosphere, and you guys think that, oh man, he's so great. I'm humbled that you would consider asking me the questions and the interactions that you have and whatnot, and I try to get back to everybody. I guess I'm apologizing to those that I haven't. I caught a couple of last night, and I'm going, wow. I should have called this person back. I tried to. But I've been dealing with some other stuff. Not an excuse, but I had some idiot pop in on my property there, and it wasn't good. So I've been dealing with those issues as well. Anyway, make sure that you're asking some good comments and questions. Because
someone said, what is the gas mix I should use with MIG on steel?
Well, if you're going to ask me a question, son, you got to speak up.
All right. He said, what is the gas mix I should use with MIG on steel?
I'll answer him in a minute. I was getting ready to say something important over here, man. Make sure that you're asking questions, because ESAB is going to give away, they're going to pick somebody out of the crew here for a Savage hood, one of which I have not had hood time on yet. So all you savages get in there and comment, and they're going to pick you out. And somebody's going to win big. That hood does look very comfortable. And I've heard comments, I've read comments on it and stuff, so get your questions going. Somebody's going to get picked out for that today. Let's get back to that question that person asked. What gas mixtures? Okay? Where do you want to go first? Because this is going to get real deep real quick. It could, anyway. Short circuiting, globular transfer, spray, pulse spray, all require different gases. And we can gas metal arc weld in the flux core area too, with or without gas. So, what gases can you use? There's 6 of them over there. Some of them aren't going to be too good. The common gases for short-circuiting transfer, like on the smaller machines that you could plug in the home hobbyist machines. The 2 gases that you can run and have favorable results would be straight CO2 and 75-25. We've been calling it C25. I don't know if there's too many other nicknames about it, just straight up 75% argon, 25% CO2. These gas blends have a lot to do with the arc characteristics of what's going on right at the arc. Okay, I used to do some CO2 work in my early days, and when I say early days, I want to say I started in 1974. In 1976, I was going to school at Pioneer Area Votech in Ponca City, Oklahoma. And in my senior year, last semester, they put 3 of us on the job training. I don't want to say we were the top 3 from different communities. Tonkawa, Blackwell, Ponca City was represented. I represented Ponca City. We went to work for a company called Heater Technology, and great experience for me. Instead of going to school, I was going to work, got paid for it, and I learned a lot. I was at a young age. It's hard to do that these days with all the insurance and all the poop going on out in the industry. You can't hire somebody under the age of 18, and understandable, but these partnerships, internships, on-the-job training opportunities, they're very valuable, but again, it does pose a safety hazard and an insurance liability and whatnot.
You ready for another?
But I started out, what?
No, I was gonna someone else ask something else.
I started out and I used a lot of CO2, straight CO2. It worked well, it was okay. It becomes unstable quickly. And when I say unstable, we start having a lot more spatter, whatever term you want to use there, spatter, dingleberries, huevos, whatever, you know. And that's okay, it has a different depth of field profile. It's cheap. By the way, it's the same CO2 that you can go to the convenience store and get a pop. You know, it's all the same CO2. When we get over into argon and CO2, things smooth out quite a bit. And to me, I have more of a range of opportunity, high and low, to weld certain things. So answering your question, and I hope I'm answering your question, if it was me, I would look at one gas and one gas only these days, and it would be C25 for short arc. If I was welding on some extremely thin material, I would go down to 023. My favorite wire for carbon steel is ER70S6, 70,000 pound tensile strength, ER. When I say ER, it is chemically equivalent to any TIG rod in that same ER70S6. It's just spooled different. Chemically, it's the same. Electrode rod. Okay. ER70S6, 70,000 pounds is solid. The 6 relates to its chemical composition in the oxidizers. Silicon and manganese are in S6. It tends to flow well. I like it a lot. Been using it a lot. I have tried some S7 wires. When I first heard of an S7 wire, I was at a corporate Ryder Cup golf event where they played the John Deere Classic, and somebody popped off about a S7 wire, and just off the top of my head, I'm thinking, well, that's got to have some manganese, higher manganese in it. Higher manganese in the presence of carbon is a strengthener somewhat. So, and that's what it had in it. We had some down here. We tested it. We ran it in all different types of modes of metal transfer. It ran well. I thought it was a good wire too, but just for common stuff, ER70S6 will get you by. Common sizes of MIG wire. Gas metal arc welding comes 023 or 025. 030, 035, 045, and it keeps going up. In my opinion, 045 is the last size wire that you can short arc with. It's a big wire, but you can still short arc with it. So a little rougher, but so what is the most versatile wire that we could get by with? In my opinion, I believe that to be 035 wire. Short arc, we can spray, we can get into some other different modes of metal transfer, we can weld thick, we can weld some pretty thin stuff. I've welded 16, or 18 gauge, I don't like it, but I have. I would change wires when I get down below 14 gauge, simply because it opens up a window for me. Instead of welding everything down on the forced to weld it down on the very, very low end, I would tend to change wires. It doesn't take very long to change wires. When you change wires, you need to look at changing drive rolls. You need to change contact tips, okay? You need to get that stuff and match it up. I've had a lot of people get a hold of me and they say, "Man, you come over here and fix my machine. It's not running very good. I can't get it to dial in. Dial in means it's singing." And I'll go over and I'll start looking at it, and they had put a smaller wire in, but all they had was like the next size bigger contact tip. So, you know, that's a problem. It's like your contact tip when it gets worn out. I think we've all been welding along, minding your own business, and all of a sudden your machine starts whacking around and it goes haywire, and then it settles down and it starts welding good again. What just happened? You know, what just happened? Well, more than likely, it could have been from something like this. I've got a tungsten holder that I grind my tungsten in with a pedestal grinder. It could have been something like this. You gonna zoom in on this there, open dog? You know what? Let me grab another wire.
All right.
Yeah, buddy. Get on in here. You got it?
Yeah.
So what's happening is if you're welding along and all of a sudden your machine goes haywire, it's more than likely because your contact tip is worn out. And it'll get a nice little oval in it. They're not going to last forever. They got wire rubbing up against them. And so when that gets ovaled out or it's worn, there is just time in there that your wire is floating in dead airspace. What energizes your wire as it leaves the gun? It's the contact tip. Everything's insulated up to that point, okay? And so if your contact tip is worn out or you don't have it sized correctly, your wire floats through dead airspace, and then that's where it can't recover. And then it bumps into the grounded material, probably bends and makes a contact tip again. Hey, I got a good question for you. You guys thought you were the only ones that are going to ask questions. I'm asking questions right here. What condition in the wire, what condition in MIG wire makes it come in contact with the contact tip? Yeah. Anybody answer with
Not yet.
with a good term yet?
Mm-mm.
Anyway, there's two conditions when you spool a wire for delivery. There's two conditions that make it come into contact tip. One of them very prevalent, the other one not so much. I'm scared to get out a roll right now because I'd probably do this, and even though I'd be providing good entertainment for the folks all over the world, I don't want to clean up the mess. Anybody hit that 4-letter word yet? No?
No one has
You
it.
have got to be kidding me. Did I lose everybody?
Let's see.
I'm looking for a 4-letter word, starts with C, ends with T. Come on. Oh my goodness. Boy, you guys in my classroom, y'all sleeping or something. Anybody ever heard of cast? Did you ever heard of cast? Anybody been putting a roll of wire on their welding machine and accidentally let go of the wire? It goes everywhere. That's cast. And that's what helps your wire come in contact tip with, or helps your wire come in contact with the contact tip. Okay? So, keep on, you know, if you have various drive rolls, if you have different setups for your contact tips, and they make an array, they make an assortment of all kinds of contact tips, the tapers. I've modified different cups and stuff. I know I have this right here. Excuse me. They have these available for your various setups. The gun that I have on here, Spraymaster on this 235, and right now I have a shorty setup on here. You'll also see some orange pucker stuff on there. That's a ceramic anti-spatter that I like to use. I've always, over the years, cleaned my nozzle contact tip while I'm welding. I know they sell a lot of nozzle nectar products and sprays and stuff like that. Personally, I don't get excited about too many of them. I've always kept these clean while I'm welding. If I finish a weld, I'll gently knock it off, or I'll gently take my pliers and do this. But I'm telling you, this stuff helps a bunch. Sparks just don't want to stick to it that well. Contact tip and nozzle. Now if you'll notice this, my camera guy, my compadre over there is getting, see, this is quite a bit difference in these two in length. And this longer diffuser and contact tip go with it as well, for a reason. When I'm doing fit up and stuff, I like to have this, and this short circuiting, I like to have the short circuit mode of metal transfer. I like to have this in here fairly short. It's a good reaction, it's crisp starts. When we get into the hotter work, when we get into globular spray, I like to use these longer ones because I like a little longer stick out, and I also like this contact tip to be recessed more up inside the nozzle. Okay? Those two conditions, I said short arc, I said spray. Electrical stick out is defined by the amount of wire past the end of the contact tip to the grounded material. It's not the nozzle. It's not the nozzle to the material. It's the contact tip to the nozzle. So if you like to run 5/8 stick out on your spray, and you have this about a 1/2 inch or so, then this would need to be recessed up in there about 1/8 or so. Is it super critical? No, it is not. There are some flux core wires that we've run that are super critical for stick out, but gas metal arc welding, it's not that critical. Here's a little short stubby rascal here, tapered. I like to run these with tapered contact tips, getting up into some tight places and whatever joint configuration you have. You know, Ian built some super off-road buggies and stuff, and I'm sure that there are angles and tubes, and he's getting up into some weird skewed type affair where, you know, it's up in here tight. That's just the way things came together. You know, it may not be the process to weld that, but it's, you know, it's possible under the right settings. Got to make some adjustments. I'm telling you, this helps a bunch. This will help a bunch. Get your contact tip up in there closer. You still get gas coverage. Don't need to do anything wild with the machine to make a successful weld. All right, where we at? Let's talk about some basic joint configurations here. Did I have any other simple pop-off questions there that needed to be addressed?
Let's see. I gotta scroll up.
The burger and fries. What? He's on his own, man.
All right, here's one. Well, no, that's not a question.
Did anybody from ESAB write in there and say, keep going,
ESAB's
off
been
topic?
ESAB's been answering some of these questions
Oh,
as
cool.
well. Yeah.
Oh, cool. So we got some product guys on here, and that's extremely beneficial. Again, folks, this is a reminder, everything is done for you. This is put on by ESAB. They've asked us to do these discussions, and if we can help with anything, you got to let us know, and that's what this forum is all about, for questions and answers. And in that, they have brought in some of their experts to answer some of your questions on the fly here. So I think it's very beneficial.
Someone asked.
I'll guarantee you, when I get off of here, I'm going to learn something. I learn a lot. I learn stuff every day, and so again, I think this is very beneficial. I'm proud to be a part of it. What was that?
Someone asked, what is the difference between short arc, globular, and spray?
Short arc, globular, and spray. Those are heat values. Let's talk about let's just keep it real simple. Short arc, the wire is coming out of the gun. Oh, God, that hurts. The wire is coming out of the gun, and it comes down and hits the grounded material. In short arc, you hear I've heard it described as bacon frying. I have not found that brand of bacon anywhere. I've fried it in cast iron, wok. I've fried bacon. I've fried all different kinds of bacon. I cannot duplicate that sound anywhere in bacon. It's a sizzling for sure. What's happening is it's a reaction that's like 50 to 200 times a second. When your machine is running good in short arc, it's like sizzling. It's nice, okay? And it's stable, it's not popping around. We've got very small sparks coming off of it. It's a beautiful thing. When you go to globular, to me, it's starting to become a little unstable. You have a hotter, more fluid weld pool. And there's a range in there that you're in the globular transfer, and you know, it's okay. I'll give you some scenarios here in a minute. And then one step above that, we get to a spray mode. A spray mode is in an argon-rich, richer environment, and it is above a transition current, okay? So, you know, we can argue back and forth about where that happens and whatnot. Think of it this way. In short arc, you hear that sizzling. In spray, the wire comes into the arc zone, and it just becomes, the end of the wire is a needle. Literally, it is a needle. Okay? You can set it where you don't hear anything. It's just a sizzle, just a fluid kind of. There's nothing. There's no popping going on or anything. I like to, and there's various gases that you can create this condition in. I like to set my machine in the spray condition where, as I move forward, I hear nothing. I hear a little sizzle, and if I move back and fill the crater, I hear a little bit of a crackle. Now here's where the argument comes from. There are, just like in TIG welding or any other process, there are correct electrode angles, okay? And this is where we're gonna, when we start talking about joint configurations and whatnot, there are correct electrode or wire angles. Those of you that have been on a simulator know that it'll score you on this angle here. It'll score you on this angle here. It'll score you on your electrode stick out or your wire stick out. It'll also score you on your travel speed. Okay? Those are the things that you control. It doesn't have anything to do with your settings. That's what you do as an operator, as a welder. In short circuiting, push, pull. Is it that big of a deal? Personally, I don't think so. I've pulled welds on certain things. I've pushed welds on certain things. I don't see a big difference. If you want to get super technical about it and cut and etch, yeah, there's a little bit of a difference in there. But you're not always gonna, you know, if for somebody to tell me that I have to drag a short circuit weld, I may not always have that opportunity. I may be working on a project where I'm forced to push it just a little bit. It's still welded and it's still fine, it's okay. When it comes to globular, let me just clear this up real quick. I think a minute ago I said, you know, those conditions, and we'll argue back and forth, and I'll give you some scenarios. Let me tell you this, if I'm doing a bunch of short circuit work, and I'm up to like, I want to say 1/4 inch material, 5/16, I have it prepped, I have it cleaned, I have a slight bevel on it, I'm doing fillet welds, I'm welding on both sides, and somebody comes in the door and they want me to weld a bunch of 1/2 inch stuff, the first thing I'm going to do is try to figure out, can I position it so I can spray it? That's a heavy enough material that I would love to spray that, because I can put a nice tight, good looking weld on, well, good looking, I can put a nice tight weld on there with mechanical properties, move faster, not over weld. So what am I going to do? Change a bottle of gas? Big deal. That doesn't take me long to change a bottle of gas out. So if you're humping along there on some short arc and your C25, yeah, you could probably turn it up to globular mode. Don't look to get into the spray mode with the C25 gas. But simply, I would just change gas. That's what I would do. I would put another bottle of gas on and adjust my values back here and run into the spray. Now, you'll see over my shoulder over here a 6-pack of gases. That 6-pack of gases was born because we have machine manufacturers that they have a machine that does a lot of different things, and I mean a lot of menus inside and everything. I don't like twisting cylinders any more than I absolutely have to. Even though I can twist 2 at a time and walk across the floor over here, I don't find that entertaining anymore at my age. If I'm going to switch up on all these different processes, you know, obviously we can't put a machine is not going to, you don't want to do this and put a machine on it. You want to build the machine, build this where you can move it around. You can manifold these gases. I have just found it very quick and beneficial to bring the gas to the machine, bring different gases. I believe there is argon, helium, C25, 95.5, 5% oxygen, 92.8, 8% CO2, and wait. Yep, there's a tri-blend of gas over there for stainless. There's a tri-blend of gas over there for stainless. I mean, you could switch those up even more. I like this because it's quick and simple for the students. We can set up a demo area over here and multiple students can get on. We can set up a process and a mode of metal transfer, rotate all the students out, they get a taste and a feel for it, turn around and put another gas on it, adjust values, see the difference, cut, etch if we need to. Everybody can get a feel for what's going on. It just seems to be very quick and simple. So that's why I did that. I recently changed it where it rolls a lot better. It had some casters on there and humping that thing up. I look like a dog trying to tear a root out of the ground sometimes. I changed these to some better casters and it moves a lot easier around the shop here. So, what's our time stamp so far? I want to get into some joint configurations and probably some adjustments. What's our total time? I can look up there. 45 minutes already.
Yeah.
I talk too much. Well, let's do this. You know, a while ago I said something about the PPE, vitally important. Your tools are vitally important. I do not have students, I do not require students to go buy the highest dollar brand, and I'm not going to name any brands. Let me grab a hood real quick, we'll tack up. I don't know who moved my hood. I had this over here all the time. I do not require students to go out and buy super high dollar stuff. I do not like them to buy the cheapest brand and go to the guys that drive around in the semis and bring junk. Invest in something quality, pay attention to your tools and treat them right. They'll be with you for a while. That pair of needle nose I started with in 1974. I bought them. That's my stamp on there. I bought them in an auto supply store. My buddy and I were standing there, and I think they were of a semi-higher brand or whatever, and I bought them. He looked at me and said, you know those things aren't going to make you weld any better. And he was right. But I still have them. They've served me all this time. They have served me. I'm going to tap a couple of joints here. I have this where it's clean on the base joint on this material. I have it where it's cleaned on either side, so I'm just going to do a simple fillet weld. And that was a mistake. I did the wrong tube. I make mistakes. I can tell right away that I need to up this voltage. I'm up the wire each. I've always grown up, I think you know my age by now, but when I started welding, all this digital stuff didn't exist. Let's listen to this and see if it's any different. Oh yeah. Okay, I'm going to make a weld like that. And this is how I set a machine. I set it by sight and sound. And obviously there's times that you can't set it by sound. Things are too loud or going deaf like me. But I watch the weld pool. Okay. People have sent me wires to test. I start out on a machine that has absolutely nothing. It has no meters, no analog, no digital, no nothing. And I'll run it through the paces as I see it. Okay? I will end up on a machine that has all digital output performance so that I can record values and stuff. But let's listen to this if you can hear it in my mic. Okay. I'm pointing the gun straight in. I have about 3/8 to a half-inch stick out. To me, and this is quarter-inch material, to me that is a little cold and slow. Okay. So what I would do on this particular fillet weld would be to turn this up to probably 19.5. I would turn the wire feed speed up to, I'm going to start at 250. I expect it to be a little slow, but again, let's take a look at it. To me, that needs more wire feed speed. Again, it's that sound. It's what's going on with the machine, with the weld tool. I'm gonna add a little bit of wire feed speed. Oh my goodness, I slipped. That's too much. Let's go up here to 250. Let's go to 270. Okay. And we'll do this one more time. Oh baby, that to me sounded much better. To me it went in cleaner. It started out, pretty sure you heard me that started real clean, real good. I always have to do that. Oh, and I want to wind down for the fan there. So on this particular material, we ended up at 19.5 and 270. We're running C25 gas, 035 wire. I mean, these are the things that we pay attention to. Any of the joint configurations on short arc, I would weld pretty much the same. A while ago I said something about the spray mode. I like to set my machine where it's quiet and it's sizzle when I step forward and a crackle when I get back. Well, that's because I cannot just take off and make a weld joint and travel like a robot. I cannot do that. I will openly admit I am flawed. I can't do it. I have to do something where I can monitor and check my movement, and that is the gentle rocking. Now, some of you will try to climb on board and dog on me and say that you're whipping it and all that. Use whatever terminology, I don't care, I'm laughing at you. It's just a gentle tip-top. You know, whipping is like what you do with 60-10, where you step completely out of the weld pool so it freezes. I'm not doing that, okay? A gentle tick-tock rocking motion allows me to mess up and still make it okay, I guess. It's just the way I move, you know, it's the way I progress. I can put the ball of my hand down and I can kind of rock and tick-tock. I've gotten into some good heated arguments with vendors and suppliers that say that you have to just, you know, steady motion and all that. Good luck. I can't do it. T-joints, lap joints, where I got my material over there. A lap joint. A fillet weld is defined as any two surfaces that come together at or near 90 degrees. You're going to create a fillet weld, right? We like to do our fillets in here. Fillets to me, for training purposes, waste material. But you can come along here. I like to offset mine. You know, offset it in these corners like this to create a little more weld area. And it also does this. We got starts and stops on edges. Plan your weld. I don't like to see stops out here. I don't like to see big craters out here on the edges and stuff. I like to start there. I also like to, there's sequencing of your welds and stuff. I like to see stops on top of starts. I mean, when you blend them all together and everything. So we got a lap weld, or got a lap joint, T-joint. One of my favorite when we get into all the other stuff. And I call this a poor man's bevel outside corner joint. And what we can do with that is, you know, we can weld it just like a groove weld. We can get 100% penetration. We prep our material and we put various gap in it. And that will constitute some of your initial settings, your wire angle, your travel speed, and all that kind of stuff. But seriously, it welds just like a groove weld. I like to come in here with gas metal arc welding MIG. This setup right here, I would probably run about 17.8 to 18.2 volts wire feed speed in about 190 to 220, and you know, get 100% joint penetration on there. It's not hard. Run your root pass in there, clean it out. You could run a cap, make it look good, blend it, all good things. Plug welds, let's talk about plug welds. And by the way, I haven't forgot the gentleman that asked a question in something like, how do you set your machine for doing lap welds on Toyota 10? We'll get to that here in a minute. A lap weld, a plug weld or a slot weld. What kind of weld is that? Essentially, it is just a fillet weld. Do you need to fill up the entire hole? No. No, you need to do the fillet weld, and if it blends out and comes together where it almost fills it up, that's fine. You know, is it strong? Yeah, that's why it's in there. I think, you know, in my experience and days coming up, when we talk about weld, how much weld is necessary, I think people need to look into taking a materials type class or get into that material. Maybe I should write a book on strengths and stuff. I know I took a lot of classes on statics and strengths and materials. We had to do a lot of calculations and stuff like that, and I thought it was extremely beneficial. Oh, it was very beneficial. Plus, I like the lab part of it where you went out and tore crap up, you know, just destroyed it. You get to do tensile pulls, and you figure out how much it took to actually destroy that part. and then you relate that back into, well, how much weld do I need to put down on this? I have seen people put down way too much weld, and you talk to some of the weld engineers and some of the people that are doing designs. You don't need, you know, if you oversize a weld, I'm trying to remember this back, if you oversize a weld, you could be possibly putting in 4 times the amount of what you really need in time, weld metal, and all that stuff. It's just not needed. Now, on the other side of the coin, if you just pull the trigger and put some real thin, quick bead in there, that's not cool either. I think we've all fixed stuff or seen stuff that was manufactured, and when we say manufactured, man, they're humping it up and they're putting some welds on there super hot and fast, and some of them even actually miss. You know, they miss the whole joint. I don't know if it's a robot doing it or if it's a person doing it, if they're paying them by the part or what, but I've fixed a lot of stuff in here. It actually takes longer to prep it, take all the powder coating off of it and the paint or whatever to clean it up. And it takes about 15 seconds of weld time, and then you're waiting on the paint to dry. You know, it happens a lot. So, you know, the weld placement, how much weld, the settings and all that. When we opened up this session, I said this is probably one of the most misunderstood processes. Because everybody thinks that, oh, we just turn it up. We'll turn it up way high, way hot, it'll go in there. That's not what's happening. When we get to that globular transfer, somebody said, well, you know, just turn your machine up. You know, just turn it up. Great. You put a weld on there and it is actually just laying on the material. It's not penetrated, it's not fused into the parent metal, it never wetted in, it's just sitting there. You know, painters will tell you that when they go sandblast and paint your work. You can stick a razor blade right next to your weld because it never fused in, and they put a coat of paint over it, and it better be inorganic zinc, and they better put some caulk on there because your weld's going to rust because you never fused into the parent metal. Take the time to prep the material. I know management hates that. I'm sorry, that's just the way it is. Needle scalers, sandblasters, grinders, abrasives, learn how to use all that stuff. This is a wide open subject. I know I touched on some things. It made me think of others that we could possibly get into with more sessions. Short sessions, concentrate on one item. When we talk about weld joints and configurations, there are so many numbers, so many subtle techniques that people use. It is phenomenal what you can pick up following some folks. I know in the past that I've called out certain people like MIG Man over in Europe. And by the way, you guys over in Europe, I appreciate your following and your support too. You guys are off the charts cool over there. I mean, there's some phenomenal work going on. You go on these pages, ESAB's page, you go on Instagram, Facebook, and you look at some fantastic work. I guarantee you these people know the numbers, they know the techniques, and it all relates back to understanding the basics and going from there. I hope this has helped. I want to do this some more, so make sure you comment. I hope somebody got picked for that Savage hood. I'm telling you right now, I'm jealous. I'm a little jealous. I got to get some hood time in there. I have certainly enjoyed this hood over the years. I got one a long time ago for filming, doing some sessions, and that was the original Sentinel that I had. and I set mine up pretty quick. I like to set it at about number, when I'm out here in the shop doing this kind of work, fab work and stuff, I'll set it up on a number 9. I'll set it up on a number 2 in sensitivity and 1 on delay, and I'm good to rock and roll. I'm good to go. I'm comfortable. Doesn't fail me. I don't have to fight the hood. Nothing infuriates me more than something that doesn't work as far as personal protective, like if the lens doesn't react like it's supposed to. That just kind of hacks me off quickly. The second one I had is like a museum piece for me. Doug Smith with ESAB gave it to me when we were in Atlanta. I started a presentation and I was nervous as a cat on a hot tin roof because, you know, I had to pull this thing. I was wanting to engage the crowd and everything. And he walked up a couple of minutes after I'd started and he goes, "Here, use this one." It didn't even dawn on me what was going on because I was so focused. He had made one, somebody made one for me special. And I got home and I watched the film and I thought, well, what an idiot. And I mean, you just kind of like slap this guy right in front of everybody. And I said, no, that's all right. I already got this one going. I got it set. And this thing was like super cool. So I came home and it is resting comfortably in my office on display. I do pull it out on occasion, but I had a gentleman come in. I call him a gentleman. That's kind of a loose term, I can assure you. This gentleman came through my program, graduated, and within a very short time was out. I mean, he was out on the railroad, actually before he graduated, but he got hired on. Within a short time, he was out in management. He's a track manager in Eastern Colorado. Kept in touch over the years, kind of, sort of, but not, you know, like we should. I think he was a 04 graduate. Anyway, he came in here right after FabTech this past year. He had been up in Kansas City doing some training, and he called me and said, "I'm going to come down and see you." And anyway, he showed up. I gave him that first lid. He don't know it, but I damn near cried when I handed it over to him. It had some history to it. I think his daughter absconded with it now, so I hope it has good use. Again, quality product. I've used it certainly a lot of weld. Teaching every day, it's held up. It's comfortable, clear vision. I don't have a problem with it. So, Joey, you conniving little thief, you got the original one that I had. Enjoy. So, comments, questions. Make sure you get back to us. Let us know what we need to do. I need to do. Ian's got another session coming up. I'm not sure if he's going to use any kind of special product to get those spikes going up like Glenn Plake, the skier, but he's going to do something next week, and I'm sure it'll be uber cool because he always does. Let me know what I need to do in another MIG welding or whatever my next session needs to be. I think somebody mentioned stick, and I'm not scared. I got the Renegade right there. I'm ready to go. So let me know, and we'll get going on it. Thank you very much. I appreciate your time today. Have a marvelous day. You are marvelous. Peace out. Thank you.
Stephen Lonsbro won the helmet.
Huh?
Stephen Lonsbro won the Savage helmet.
Somebody won that Savage hood? Get
All
their
right.
address. I'm gonna go visit. I gotta get some hood time on that thing. I'm curious. I've seen those painted up, and somebody's got some. There's a couple of custom ones I saw on Instagram.
Everybody said thank you for the class, and yeah. Stand it.
Yeah, I guess. Go ahead and end it.